Hi, my name is Vibhu Yadav and today we'll be solving LeetCode problem number 133, which is also called as clone graph. In this problem, we are given a connected undirected graph and we need to return a deep copy of the graph. So the graph is represented using adjacency list and the constraints are not that much high. The number of nodes inside the graph would not exceed 100 and the values of the node would be in the range between 1 to 100, and the graph is connected and all the nodes can be visited from starting the given node. Okay, so it's a traversal problem, graph traversal problem, which could be solved using either DFS or the breadth first search. So if we look at the related topics, so it says DFS or breadth first search. So we'll be solving this problem using DFS approach. So let's just look at the example. How could we solve this problem? So let's suppose I have given the starting point of the graph as the one, or the node 1 is my starting point of the graph. So while traversing using recursion, we'll be asking two questions to us. The first question is we'll be asking whether this node has occurred for the first time inside the recursion, or is this node has been processed before. So let's suppose at starting the DFS1, in that case this node is occurring for the first time, then in that case we'll simply make a replica node of my current node. So we call the DFS for its neighbors, that is for 2 and 3. First we consider DFS for 2. So we again ask the same question, whether is this node occurred for the first time or not. So this node has occurred for the first time, then we again create a replica node for the node 2 and we call the DFS for 1 and 3. So while calling the DFS for 1, now we ask the same question, whether the this node has occurred for the first time or not. This node has already been processed, so it is occurring for the second time. So in this case we won't create a new replica node, we would just be making connection, that is adding edge between the parent and the caller node. In this case we would be just making an edge from 2 to 1. Now we call the DFS for the second number, which is 3. So it says the 3 is occurred for the first time. We again make a new node for the 3 and call the DFS for 1 and 2. So the same problem again comes. The one node has already been processed, so we just simply create an edge and we do not create the replica node again. And similarly for DFS for 2, it has also been created. We simply create an edge between the parent and the caller node, that is 3 and 2. The function stack goes back to the function DFS for 2. It has already solved for 3, so we just simply make an edge between 2 and 3. So in this way our this problem could be broken down. So if we look at the recursion tree which I was talking about, so the recursion tree would look like something like this. At every point we'll be asking the question that is this node occurred for the first time. If that's the case, we allocate a replica node for the same. If that's not the case, considering, let's suppose the example here f2, so for f2 here is occurring for the first time and f2 here is already been occurred. So in this case we'll be just making edges between 3 and 2. So the time complexity of this approach would be the number of vertices plus the number of edges. So if we look at it, so the time complexity for this particular case is 6, because we are having 3 nodes 1, 2 and 3 and 3 edges. So our we have like run this algorithm for 6 steps. So the answer comes out to be in V plus E. So let's just quickly go and write the code for it. To keep track count of the visited nodes, we'll be having a map in which key is my node and the original node, and value is my replica node. We initialize this map. And we simply write a function, a DFS function, DFS node, and we pass this node to this DFS function and return it. Now let's just name it visited. So if node is equal to null, then we simply return node. Else, if that's not the case, we ask question if visited already contains this node, meaning that the replica of this node has already been created, so we won't be creating another replica, we would be simply returning the replica. If that's not the case, it is coming for the first time, then we simply create a replica node. With node.value, we marked this node as visited by making an entry inside the map. Node, and we call DFS for the neighbors. So at this point we'll be getting the neighbors for every node. Like when we are like the recursion has gone the depth, we are standing at this node, we call the recursion for DFS for 1 and 3. So when we call the recursion for 1, the node 1 was already created, so it returned me the reference of the this replica node to the 2. So we'll just add this. So at this step we'll get the neighbor replica and we link it with my current replica node. So that is the step, like replica node not neighbors dot add then, and we simply return the replica. Right. says error unexpected node DFS. Okay, node sorry. Yeah, it passes. Can like submit it and run for the, yeah, it is like run successfully run and gives us 25 millisecond. And it is similarly we could also code the same idea using a queue based technique, that is using breadth first search. I will be sharing that solution in the description section. Please like the video, help me know where I can improve upon. Thank you guys, thank you so much.